Welcome to the third session, just before lunch here. We're going to talk about functional libraries for Java 8. So please welcome Rabea Gransberger.
So good morning. This is actually my second time at JFocus here and in Stockholm. Still didn't have the time to do any sightseeing, so last time I've been here in Stockholm it has been foggy all week, so I didn't see something as well, so maybe I will have some time on Sunday. So what we're going to do today is we will have a look at 9 different libraries. I'm not showing really code, I'm just showing it on the slides, because that way you at least get some impression what you can do with the libraries. I have some full source code examples on GitHub, where you have all the 9 libraries included in just one repository, so you can just check it out and play around with it yourselves. When I actually prepared the talk, I got really distracted by the libraries because it was so much fun to play around with some of them. I really forgot to write or continue with the slides. So I hope you have some fun with it as well. And why this talk? Java 8 has some functional, stylish additions. It's still not a functional programming languages, and what they added still isn't really functional. We have the single abstract method types, which now enable us to do something which looks like we are passing around functions. It's still types in the background, but the good thing is it's all backwards compatible, so we are having the functions and we can still compile to Java 7 if we were doing some tricks with retro lambda, for example. So with these new types we got like a function, predicate, supplier, and consumer, which have been added as some basic SAM types. We can produce values, consume values, and transform the values with some functions or filter them with the predicates. And we also have got default methods added, which allows now to directly call the sort method, for example, on an array list, which is also very nice. And then we can pass in a number for example, comparing persons by their name. And it also allows us to do some functional stuff with it, like, for example, composing some functions. In this case, we have a B function. Yeah, it's everything on the screen, perfect. We have a B function, and we're going to add 2 values together, so it's x plus y. And then we can compose it, because we also want to do a multiply. So we call the method AND-THEN, and say multiply the result we previously got from the function by 5. And then we can pass in our 2 values with the apply method. So we pass in 2 and 7, so it's 2 plus 7, which is 9 multiplied by 5. The result is 45. So this is some functional style that you can compose actually 2 functions together to build a new function, which you can then use. And with the streams, we now have some intermediate operations and some terminal operations, which allow us to do the filter map reduce, which has been known from other libraries previously as well. So the difference between an intermediate operation is that you still are on a stream, so you can apply some more intermediate operations. And with the terminal operation, which is usually a reduce operation in some different kinds, like count, for example, gives you just the number of elements which were in the stream after your intermediate operations. So you get just one result back and are not on a stream anymore. And one thing about Java 8 streams is that you can only use them one time. So if you have called a terminal operation, then you can't use the stream anymore. It becomes invalid. What we usually do in our office is when some employees have a birthday and it's more than one. If it's only one, they usually bring some cake or something. If it's more than one, they really like to organize a birthday breakfast for the rest of the colleagues. So they have to organize themselves and see who has a birthday on the same day. So I thought what we probably can do is just build an automated system which goes over the employees and finds their birthdays and sends an email out for all the employees which have a birthday this month if they maybe want to organize a breakfast together. So let's see how we can do this with Java 8. So we start with some persons, employees we get from a database, and we call the stream method on it. So we are now on the stream. And so we filter them first for all of them which have a birthday. We get the months of the birthday, and we just want those which have a birthday in this month. And then we can group them by the same day. So we just want the month and the day, because the year might be differently for the birthdays. So we get the month and the day, and we group them. So collect is a terminal operation. So what we have now is a map of the birthday to a list of the persons, actually, which have the same birthday. The problem is, first of all, we have to remember that we have to call collect. So I always want to start by typing dot and then group by. Oh no, I have to call collect first, and then pass in the grouping by. And then I have to continue, right? I still have to send the email, so I have to start over again and calling entryset.stream. And then I have to filter those, because we only wanted those with more than one person with the same birthday. And then we still have to sort them, so we can have the ordered email list, and then we can send out the email. I mean, it does really look nice compared to what we had to do previously with all the for loops and so on. But it's still, I mean, Lambda reminds us of Lambada, but it looks more like this limbo style, right? We have to go underneath this handlebar, which is on fire, so we might burn ourselves. So we want to have a look today if there are some other libraries which can actually make our life a little bit more easier, even to those additions we already have in Java 8. So before we start, I don't really want to put any blame on Java 8. I think it's very great what we have, and it's really enabler, because they enabled the lambdas, right? The other libraries are going to use them, but otherwise it wouldn't have been possible. There's also other JVM languages which are much more functional. For example, we have Frege, which is a Haskell implementation. So anybody has worked with Haskell before? Great, so you might want to use something else, even if you want to run it on the JVM. And Java is very conservative in adding new API, so they gave us some of the basics for filter, map, and reduce, but they didn't give us anything we might really think of, so you might have to write your own collectors or something like that. But the good thing is they're probably going to add some API later. With the situation we have now, for example, with the optional .get, which is, I think, already deprecated for Java 9, because it didn't make any sense. In this kind, they haven't been that conservative. It's always better to add the API later than to remove it. You know, we don't want to go from one release to another and have half of it deprecated. So it's much easier that they have a look what the community is doing and analyze the GitHub repositories, for example. If everybody writes the same collector, which looks the same, maybe they're going to add it to the API. And what I really want to give as advice to you is, please, before using any of these libraries in production, please make a little example, test drive them, if they're actually performant enough to what you want to do, and don't just use them. And like I said, if you need binary compatibility with pre-Java 8, you can try RetroLambda. It might work for your releases as well. So if you have to serve older customers, that might work as well. So first we start with some additions to the Stream API, always referring to the example I gave previously, and see what some other libraries have to offer. And we're going to start with a StreamX library, so it's Stream Extensions, so very simple name. And what it does is it wraps our usual stream, so we can construct it with a StreamX off, passing in the original stream, or we can just create a new series with these factory methods. And it allows parallel execution, just like the normal streams as well. And it has some nice things to it. For example, some shortcutting collector stuff, like you can call joining directly and don't have to call collect and then joining first. So I think this is kind of easier to read. Also has some additional collectors, so if you just want to use the normal Java 8 streams and want to have some additional collectors, there's also classes for that. And it has special streams and collectors for primitives. If you're doing a lot of calculations with primitives, for example, it's always takes a lot of time to convert between the primitives and the wrapper classes. So there's some special streams and collectors for primitive handling as well, which don't do that. Another good thing about the StreamX stream is that it actually implements iterable, which the normal stream doesn't do. So if you have some existing API like this with the print emails, which takes an iterable, you're not able to do that with normal Java streams because they're not implementing the iterable. So you would have to change your method. If some of you have attended the talk of Nicholas Parlak yesterday about Java 8 Expert, you might have seen that it's probably not a good idea to actually allow methods to pass in a stream, because you only can use a stream once, and then somebody has to take control over, has a stream already been used, and it's kind of, yeah, you kind of might run into all kinds of problems when you do that. So what else can you do to constructing the StreamX? It has a lot of different factory methods. For example, of lines to construct a stream from a file. This is one thing I'm also missing from Java 8. Of keys or of values if you want to pass in a map. And a lot of other things like a Cartesian product if you want to combine two lists together and having tuples out there. Splitting some string and returning a stream directly. Zipping, which means it's like the Cartesian product, but you're not getting out tuples, you're getting out single elements. And then of tree to actually parse tree-like structures directly into a stream, like, for example, a file structure. So it gives you some handling for it to actually flatten it. And then we have a lot of instance methods. So previously we were constructing the stream, and now we're going to actually use the stream. So we have the StreamX of 1.2, and we can call prepend. So we can actually prepend values to our stream later. Before actually calling the terminal operation, that should still be possible. So we can prepend a 0 here and have then a stream of 0, 1, and 2. This also works for append. Then we have folding operations. So folding means coming from 3 different values, and we only want 1 value in the end. So we're starting with 0 and then adding the values up by using a function which will do the adding up. So it's 0 plus 1 plus 2 plus 3, and the end result is 6. And we can start from right or from the left-hand side. And then we have a method called group runs, which will group adjacent elements based on a function we are passing in. So in this case, I want a grouping of all adjacent elements which are equal. So if we're starting with A, B, A, and B, the only adjacent elements which are equal are A and A. So what I'm getting back is actually a stream of a list. So this one is a list in the braces, and we only have 1 element here, 1 element here, but here we have 2 elements because they're adjacent. So you can pass in your own function and tell the methods which you want. And there's also a distinct method which can not only give us distinct elements, but distinct elements which are at least available 2 times in the stream. So in this case, we have A and B 2 times, and C only 1 time, so C falls out of this operation. And if we are looking back at our example, one of the points I didn't really like was that we have this by date entry set, so we have to start over again, right? We can't just continue with our processing. And here with StreamX, we are just constructing a StreamX of our persons, and then we do some filtering. Then we do some sorting first. So we're sorting by the month and day first. And then we can use this nice group runs method to give us all adjacent elements directly in a list. So we then have a stream with a list. So we already have all our elements, which we previously have done with the group by function. Then we can continue with filtering and for each. So this group runs method, like you can see, it behaves a bit differently than the methods we have previously known from the streams. So it's kind of a mixture of an intermediate and a terminal operation, right? We can directly continue, but it's still kind of a terminal operation. So by calling this method, it has to process all the elements previously in the stream, and then basically starts over with a new stream as well. But we have this fluent style here. So don't confuse the different concepts. And now we have another library, which is very similar to the StreamX library. It allows us some more stream processing operations, but it has some nice additions. So this is not the logo here, but it gives you a spelling hint because it's called Jool. This is the brother or sister of the Juke library. Anybody using that? The Juke library for creating SQL queries? Nobody's using that, so you should maybe have a look at it. So it has some really SQL-style implementations and collectors and so on. It is a bit different. Oops, sorry. It is a bit different than the previous StreamX because it's always sequential and ordered streams, and parallel has no effect. It has a parallel method because it extends the real stream, but it has no effect in this case. So if you have to do some parallel stuff, that doesn't work with it. So we have all these SQL-like collectors like rank and mode, and it also has some more additions to the functions. So it has interfaces from function 1 to function 16. So in Java, you only have function and B functions, so you can have up to 2 parameters. If you need some more parameters to be passed in, this is really nice, and it also has tuples for 1 to 16 values. I mean, 16 values is what we can do in Java is just use a list for that, but then it doesn't tell us how many values are in there, right? It's really hard for a library which calls us to find out how many elements are in there. So this is much more expressive. So what you can do is create a tuple with 4 elements here, 1, 2, 3, 4, and map them to a single long value, for example. So this is a tuple 4, and this is a function 4, and we can just multiply all the values v1, v2, v3, v4, and then we get out a single value. It has a lot of factory methods as well, like directly casting all elements if we're getting then an in from a stream, and we just get a stream of objects, for example, we directly cast them to a different class. We can repeat the stream indefinitely, like for example, or repeating it for 2 times or something. We can also pass in a parameter for that. It has scan left and scan right, which is like folding, which we have seen previously, but with intermediate results. So you get still out the same number of elements. So we've previously seen like folding 0, 1, 2, 3, and we got out 6. And with scanning, we get different results, like 0, we get out 1, we get out 3 for 0 plus 1 plus 2, and we get out the 6 at the end as well. It has grouped, which is like grouping in the JDK8, but it doesn't give us back a map. It gives us back a tuple 2. And then we have ranging, so different forms of generating streams with from and to. We also can pass on a step. So if we only want to get even numbers, for example, then we can say 0 to 20, step 2. To only get the even numbers, then we have to start at 2 probably. We have unfolding, so it does a different way around. Who has been here in a previous talk might have seen an unfolding operation as well, so it's the opposite of an operation to folding. And zipping operations as well with tuples and streams. And we also have some nice exception handling. So if we are working with normal streams, or even if you're working with a sequence here of Jool, and if we are doing any I/O operation like reading the lines from a file, this will give you as an I/O exception, and usually functions and all other lambdas don't allow any exceptions. So what we can do here is, instead of a single line or single expression lambda, we pass in a body, and we handle this as exception and throw it as a runtime exception. You know, never swallow exceptions. So always do something with it, at least wrap it with a runtime exception. And Jool can actually do this for us. So it has an unchecked method, which actually does the wrapping for us. And it's available for all different kinds of stuff we have in the usual JDK libraries, like if your predicate might throw an exception, you can also wrap it with unchecked.predicate and so on. So you can just use normal streams and lambdas for it. So some cherry picking of the actual instance methods. We can directly format the constants of the stream, which should only be used for debugging purposes to just have a quick peek what's inside of the stream. Intersperse is adding an element between each existing element of the stream, so we're adding a 0 here between the existing elements. And then we have all kinds of SQL-like functions, like a left outer join, for example, so taking all elements from the left side and join them with each matching element from the right side by giving a join criteria. Right outer join, the other way around, and then inner join, only the matching elements from both sides. So to get back to our old Java 8 example, let's have a look how it can be done in Jool. So like I said, it has this nice group function, which will not, like a map function, give us back a map. It will give us back a sequence of tuples. So now we have tuples from one state to a list of employees. And then we can filter them, sort them, and send an email. So it's much more concise here. But again, it's only a half intermediate operation here. Then next, what we have is the window function. So who has ever worked with a window function in SQL? Only very few of you. So now you can learn what a window function is, because it's very, very powerful and very nice to use. So our example here is actually what I have on my bank account. So on the 1st of September, I had €0, and then I withdrawn minus 20, so I had minus 20 on my bank account. Then I had a deposit of €100, and then minus €5 again. So what's the final balance on my bank account? That's what we want to know here. So let's take this as an example and transform it actually to tuples. So we have a tuple 2 here with 2 values, and we just see what has been withdrawn or deposited on the bank account. So on the 11th, I have minus €20. On the 20th, I have the plus 100. And on the 27th, I have the minus €5. And what we're going to do now is calling the window function. So we have a stream now of all of our tuples, and we're calling the window function. And what does the window function do? We want to compare the values, so this one. And we say we want to include everything which we can find. So every value we see it later. It's kind of hard to explain. So what we do now is we are going through all the tuples, and we're starting with the first one. So we're taking the one from the 11th of September with the value minus 20, and we are trying to find its window. So we're going to go through all of the values, going to all of the ones comparing by the value 1, so by the dates here. And we're going from something which is smaller than it to the value at maximum itself. So we're comparing by the dates and looking for all which are smaller to it, so to long min value, to the value itself. And so for the 11th, we only get the 11th out, right? Because there's no smaller date than that. For the next one, for the 20th, we get the 11th out and the 20th out. And for the last one, we get all the 3 tuples out. So this is our windows, right? So for each of the elements in the stream, we're calculating their windows, which means all the related values. And we're passing in the function what we want to actually look for, what we think is related. And then it gets very simple. So if we have our windows, we get the window, and we say, OK, with the value of the window, which is our tuple 2, we concat another value. So we get from tuple 2 to tuple 3, so from 2 values to 3 values. And we calculate the sum over all of our window values. So we're adding up all the values of our windows, and if we have nothing in the window, we return 0. So what it does is, for the first one, where we have only one value, we have minus 20. And for the next one, we have minus 20, and plus 100 is 80, and minus 20 plus 100 minus 5 is 75. So this is our new tuples now, right? You were adding from tuple 2, which we have above here. We are going to tuple 3. and adding all the values. And then we can simply fill in our table, and we're done. So this is what window functions can do for you, calculating a running sum or something like that. Very, very powerful. And now you can also do it in Java as well, not only in SQL. So let's go to some more simple stuff, like some more additions to streams. Do you know what is the basics of a stream? The basic class of a stream, where are stream values coming from? So there's always a splitterator in between. So if you go in for a stream from your array list, there's always a special splitterator implementation, which is actually producing the values for the stream and allowing the stream operations and telling the stream operation it can be parallelized and so on. So if you want to have a look at some different splitterator implementations, you can also find them on this GitHub account. And there's also some more collector utils if you're looking for some more collectors. So we also have a cycling function here. So if you want to repeat your stream for 1,000 times, you can do it with this simple streamutils.cycling, and you're still getting back a stream. So it doesn't add it has no extension to streams. It's just wrapping a call around your existing stream and transforming it. You're still getting out a JDK8 stream. We can also group elements. So if we group them by twos, so we get a list, a stream of a list. We can repeat elements 2 times, very simply. We can get them rolling, so rolling pairs here, A, B, B, C, and so on. Zipping is also possible. And we can also say interrupt at a certain element, like a poison pull, for example, if you're processing some streams and you want to stop at a certain point, or gating, which means starting at a certain point. And if we actually want to use the collector utils here, going back to our previous example, what we can also do is have a collector which actually returns a stream. So it does a grouping by operation, but gives us back the values as a stream afterwards. So we have still this terminal operation, but we can still have the functional style. So if you don't want to pull in a big library, you can also write the collector yourselves. So let's change the topic. Get away from the streams and the streaming and have a look at some logging magic, which you can do with JDK8 now. Let's just have a look at the additions for log4j logging. So previously to Java 8, you always had to wrap it with this logger is trace enabled or is debug enabled or whatever to actually log some long-running operations, because otherwise the long-running operation would have been executed. Right? You don't want to execute a long-running operation. You only need to log when you're tracing. And with Java 8, you can now pass on a lambda. So instead of directly executing the operation, you just pass under the lambda for it, and then it only gets executed if tracing is enabled. And this also works for info printing as well. So if you directly have to concatenate something here, you can also pass a full lambda expression. Then let's go to testing. We have the JUnit 5 library here. JUnit 5 is also known as JUnit Lambda because it was made for that by a group of people when Java 8 came out. They wanted to use lambdas as well for testing. So what we can do now is instead of having this assert equals method, the first thing is we always had to pass in a string first. Now the string can also go as the last parameter, which is very nice. I always hated it because I can't really read my test if I have to pass in the message if something goes wrong as first. And we can also use lambdas for this as well, so it gets lazily evaluated only if the assert fails. So JUnit 5 is now in milestone 3, and it's going to be its final release, hopefully, in March, I hope. So what else can you do, or what else features does it have? It doesn't really have to do something that's functional, but I'm going to show you this anyway. So now you can define a display name for your test cases. So it doesn't have to be this method name anymore. You can freely define it with an annotation. Your tests don't have to be public anymore. You can tag them, so you can have fast tests, for example, which you want to execute in your continuous integration system, for example, and you can have slow ones, which you only execute once at night. And you can actually filter for those then. You have parameter injection. For example, you can let JUnit inject a test info, which is always available, and then you can print out the display name, for example, if you annotated it yourselves. So what else can we do with, we don't only have assertions, single assertions anymore. So if you wanted to assert two different things in your test case, you always had to write two test cases, right? Because only the first one would have shown up. If both would have failed, you would have only seen the first one. Now you can call assert all and pass in a number of lambdas. So you just have the assert and the lambda expression, and they will both get executed, and they will both show up, right? So this is the same expression here, and it shows up at John, expected John, but should have been Rabea, and expected user, but actually was Gransberger, like that. So you can have multiple failures in one. They have some additions to actually test for exception handling. So previously you had this annotation if you were expecting an exception, and now you can just pass in a lambda, say which exception you're expecting, and then assert and equals if you want to test for some parameter of the exception, for example, but it will fail anyway if this exception is not thrown. But you also get the exception back and can do some additional assertions. This also works for timeouts now. This has been recently added. So if you want have an operation which has to be executed within 10 milliseconds, for example, and in this case, I'm passing in an operation which just does the sleep for 100 milliseconds, and it will then tell me we exceeded the timeout of 10 by 90 milliseconds. All right, what do we do if we have a lot of tests which basically look the same because we have a calculation and we want to test the same characteristics? In this example, we calculate all the Fibonacci numbers in a certain range, and we want to test if they are odd, if they are all odd numbers. So what we do is we write a single test. So for Fibonacci 1, we test if it's odd. For Fibonacci 2, we test if it's odd, and 3, and so on until 20, right? It's not really readable. Nobody wants to read it. Nobody wants to write it. So with JUnit 5, we can now do something like that. So for all Fibonacci numbers from 1 to 20, we just create an in-stream. We map them to their according Fibonacci number, which just calls the function. And then we say map to object with the Fibonacci number coming in, and we are creating a dynamic test case. So with a dynamic test case, we're giving it a name. This is the first parameter, and the second is the test body. So in the test body, we're just saying, okay, test is odd with our Fibonacci number. And then we're adding some magic to it. So what we actually do is returning this. So this is a stream of dynamic test cases, and it's a test factory, so it's creating tests for us. And it will show up nicely in your IDE as well. So we have all the different Fibonacci 1, Fibonacci 2, 3, 4, 5, 6, 8, and so on. And it all shows up in different test cases, but it's just a few lines of code. Okay, I told you we're gonna have some functional libraries for Java 8, right? So I was a bit of cheating because they are not all really functional. So the first ones we have seen are just additions to streaming libraries and some libraries which now accept lambda expressions. And so yeah, some might say, okay, functional, right, is a next evolution step over object-oriented. Well, it might not be like that, but let's have a look what functional programming means. So in functional programming, functions and values are treated the same, so we can both pass them around. In Java 8, like I said before, it's still types in the background, right? We have our SAM types, so it's still mapped to types. So it's not really functions passed around, it's still types and instances of types. And what pure functions mandate is for the same input, we need always to have the same output and no side effects. So that is a pure function. So this one might look like a pure function, right? We are calculating the results on an array list, and what we expect to get back is the values A, B, and C. What we actually get back is Nothing, because it removes everything. So this is not a pure function because it modifies our input values, so it has a side effect. And so we should favor immutable data structures here, and this is, for example, brought to us by a library called JavaSlang. What they're doing is they're just using the same names for data structures like we have them in the JDK, like list, sept, and map in different variations. And so you just have to organize the imports if you're using that library, and then you have some immutable data collections. What we can do with it is actually quite the same like we have seen before, but let's have a look at another example first. What we can do with this is another characteristic of functional libraries. It's called currying. Currying is basically fixing one of the parameters of a function. So if we have this adding method again, like a sum of two values, a plus b, and we can call curry it and say apply 2. This fixes the first value to 2. So from a function of 2 parameters, we're going to a function of only 1 parameter. So if we then call this function and apply 4, the first value is fixed, so it's 2 plus 4, and the result is 6. So that's another characteristic of functional libraries. And here we have another one, which is called lifting. Lifting converts a partial function, which is only defined for some input values. For example, division is only defined for some input values. Dividing through 0 will throw you an exception. That doesn't work. We can lift this operation, dividing by 0, to a total function, which is defined for all the input values. So we are just adding an optional value in the end. So we are lifting this function divide, and we'll automatically add this optional in the end. So if we are now dividing by 0, we get back a none. So we get back a result and not an exception. So going back to our original example, what we can do here now is we don't need streams anymore. We can operate directly on this JavaSlang list. So we just have a list of persons, and these operations, which we've previously seen on the streams, like filter, group by, and so on, are directly available on the list. But remember, the list is immutable, so you're not modifying the original list, but you're always getting back a new list after each operation. So you can call them fluently, but it's not like the pipeline style we have in the streams. Okay. Another new topic. Let's see what the time says. Still have a few minutes left. So SQL, Jink. Who has used .NET? Who knows Link? So you can. There's some people which are starting to implement something like that for Java now. This is called Jink. And what Jink does is, if you have this SQL statement, select the names of a city where the city has a population of over whatever that means. Let's have a look here. See, you can, the others, underscores are really, really useful because now we can see it's 25 million. With Jink, you can actually use a stream of your database and stream all of the cities. So it does a select statement where we have the population, and then you use lambdas. So, and from this lambdas, the above SQL gets generated and executed on your database. It's still kind of proof of concept. It already integrates with libraries like Jool, for example. I also have a working example in my GitHub, but it's still, I think it's not ready to use yet. But it's a nice approach. So yeah, reactive programming. With reactive programming, like we probably have seen beforehand, we also need a lot of lambdas, right? So we can configure all the magic of reactive streams and so on. And the simplest example we actually have in Java 8 is the completable future. Did anybody use the completable future? A lot of you. Do you like the API? Any of you? Not really, right? So for me, it's kind of hard to read. So what is the end result, for example, of this? We are reading in a list from somewhere, and we're having a completable future. We then call then apply. Transforming the list to something, so we have read in the list. in case of an exception, we probably want to print out a failure, and in the end, we just say, okay, print out the results. So what is coming out of here? Anybody knows? So in case of an exception, it will print out failed with the message of the exception. In case it succeeds, it will print out this string, list, read, and the list elements. Because that's what we say here. Then apply transforms the result to something else. And just in case of an error, this one is executed. So for me, the naming is kind of confusing and it's kind of hard to read. So another possibility is here to use RxJava. Another thing is you can also use a library called JDeferred, which is kind of like promises for JavaScript. If some of you have used JavaScript, they're kind of easier and nicer to read. So JDeferred is also an option for that. So RxJava, what does RxJava do? It basically creates a stream of different inputs and lets us transform them in different ways. So the simplest example is just we provide a list of values as an input, but we can also connect it to a database, connect it to a web service or something else. Anything which provides us some input values can be connected. So for simplicity, we are now using a list in this example. And we say we are creating an observable here, so this is kind of our stream. And we say subscribe. So subscribe, in this case, with the terminal operation, will print out all of our values. What is really, really nice about RxJava is if you couldn't understand the flat map operation until now, maybe this helps, because it has in its Java doc all these nice marble diagrams which explain the operations to you, which can get very complex, and it's really, really helpful to actually use them. So a very nice characteristic is, like I said before, you can only use a stream once. If you have used it once, it's basically done. With this observables in RxJava, you can subscribe to it multiple times. For example, on top here, we do a filtering operation and filtering the strings, so we have get those back with which start with an R. And then we can have multiple other operations. So in this case, we are mapping the filtered stream and we're mapping it to its length and then printing out it. And in this case, we're leaving it unmodified and we're just printing out the names. So we can have multiple operations at a certain state of a stream, kind of. So yeah, it basically has all the operations we have seen before, which are also available on the stream. And what it really can do very well is handling time. So if you, for example, want to produce values every second to do something with them. For example, if you want to print out hello every 1 second, you can do that with RxJava very simply. You say, produce me value every 1 second, and then you just map it to hello and print it out, for example. So it's very good in handling time, and handling timeouts and back pressure, like you've seen in the previous talk maybe about the akka reactive streams. So best is just to grab the source I have on my GitHub repository and try it out. There's a very funny example where you can see how it handles time. Also has some error handling code, so on error resume next or do on error. I think it's much more convenient names than those of the completable future. So a short example of microservices, Vertex here. Vertex has a lot of different integrations as well. It is mainly used as a microservices kind of thing, but it's very unbiased, so it can be used for creating any reactive applications on the JVM. As a single example, you can start a very simple HTTP server, which handles your requests by responding with hello world here. So you will register request handler with a lambda, which says, OK, end this with hello world. And then you start up your server by listening on port 8080. If it starts up successfully, you say, OK, please go to localhost 8080, and otherwise you print out an error. So this is a very simple way, actually, to start with an HTTP server. Or you can also read in a file, for example, if you don't want to do any web-based stuff, like me, for example. I'm just developing desktop applications. So, but it's still very nice to use. And actually, like 2 weeks ago, I remembered using Vertex because I had to integrate with the server of one of our companies, and I was just writing myself a simple test server which behaved like their server, so I don't always have to dial into VPN to just being able to do some integrations tests. So it just took me 20 minutes to mock up some HTTP GET request and return back an XML. So it's something very simple to do with Vertex. So this afternoon, we actually have a longer talk about Vertex by Bersata, if you want to know more about it. Very nice stuff they're showing. So, summary. Today, we have seen some of these libraries. Actually, there's some more in the slides. So we have covered these first ones. Assert.j is also on the slides. We have Eclipse collections in the slides, and Cyclops React, which I have not shown today because we didn't have enough time. So you can download the slides and have a look at what I've dug out about these libraries as well. And you can also play with them with the source code. And there's some more libraries which I didn't really cover because I didn't have time for it, like the akka streams we have seen previously, and some more nice reactive and functional stuff. And so you can grab the slides and the code from my webpage. You can write some feedback to me on Twitter. It's very welcome. Also, what I might have been done better in the talk. It's also very welcome. And do you have any questions now? Anybody? There's some at the top. You have to scream.
How does Java slang compare to using the Scala library in Java?
How does Java slang compare to using Scala in Java? I have no idea. I've never used it. I don't know. Can't reply to that, sorry. Any other questions?
I think that Java slang looks quite much like Scala.
Okay, so the answer was Java slang looks like the Scala collections. Anybody else? Or you can just find me in the hallway somewhere. Don't be shy, just ask your questions if you like to. And have a nice rest of the conference, and thanks for listening.
Thank you.